Hi, today's tutorial is on a geological geometry question. It's the 2016 Ordinary Level Section C question 1. Okay, here in front of me you see we have the question which is the optional choice in the section C. So this question in particular will do part A to start with. Okay, so the accompanying map located on the back page of section A shows ground contours at 5 meters vertical intervals. Okay, so that's the first thing we need to note, is that the intervals of the contours is 5 meters. Okay, so basically first thing we're asked to do on that is part A, as you see here. On the drawing supplied, draw a vertical section on the line AB. Right, so if we look at the map, we'll see the line AB in which we have to draw the vertical section. Right, to start with, we just look at the line AB just to identify the heights and the altitudes of the contours that range between point A and point B on the map. Okay, so looking at that from our lowest to our highest, look at the different contours we see. At 15 meters high is the lowest, and that rises up as far as 45 meters high. Right, so the first thing we do on that is we draw our heights in on this blank section above at 5 meter intervals. Okay, so I'm just going to mark in those intervals first of all, and we will begin to draw the profile. So here I'm just drawing a vertical line up at 5 meter intervals, marking in my heights, and I'm just going to draw those lines horizontally across this blank section. Okay, so all these lines, I'm just going to draw them the full length across, so they are representing the height of the contours on the sheet. Alright, so as I said again, I'm just going to mark them here along the edge. I'll mark them here at the different levels ranging from 15 all the way up as far as 45. So we have 15, 20, 25, 30, 35, 40 and 45 is the highest point on that profile. Right, so next thing we have to do is just to identify and determine at what height these contours are going to appear, if you like, on this vertical section. Okay, so basically what we're looking for is the profile of the hill if you were to look at it in this direction of the pencil along this line. Okay, so basically I'm going to bring the points up from on this line AB, the points where these contours intersect that line right across from point A to point B. I'm going to bring them up. If you see, I start here with this first point on A, which is on the contour at 40 meters high. I'm going to bring that up and I'm going to mark that on the corresponding height here, which is 40. So likewise with the next one, I'm going to bring that up to the point where it hits the contour at an altitude of 45 meters. I'm going to continue on through those and bring them all up to the different heights. I've actually forgotten one height here at 50 meters, so I'm just going to mark that in there again, and that's at 50 meters as you see. Okay, so I'm going to carry that up to the 50 meter contour and plot that point. Again, as I was saying, just going to carry on through with all of those until we have all my points plotted. Okay, so now you can see where those lines, those corresponding contours meet at the altitude given here in my vertical section. Okay, so basically looking back to the question, what we were asked to do was on the drawing supplied, draw a vertical section, so which is the profile on the line AB. So if you were to slice through the land, if you like, at this line AB, this is the profile you will get from that shape. Okay, so I'm just going to join those points, as you see here. No harm to use coloured pens just to make that more identifiable on the finished drawing. Alright, so if that line were to extend further on to the land, you would extend it on as you see here in the profile, but because we've been asked just to draw the section through where the line AB is, this will suffice for that question. Now that we have completed part A of that geological geometry question, we'll move on to part B of the question. Okay, so part B. CD is the centre line of a proposed roadway which is level at an altitude of 35 metres. Okay, so the key points to mark there is that the roadway is level and the altitude of the roadway is 35 metres. So using side slopes of 1:1 for both the embankments and the cuttings, complete the earthworks on the northern side which are necessary to accommodate the roadway. So hence you're just asked here to do the earthworks on the northern side of the road. Note, the earthworks on the southern side of the road have already been completed. Okay, so if we just look at the exercise, as we said, on the southern side of the road we already have our earthworks in place. So to start off, what information do we need to look at? Okay, so between our contours we know that we have altitudes of 5 metre intervals. Alright, so ranging again from 15, as we said, up as far as 50. Okay, because the roadway itself is actually level, we know that the contours will run parallel to the road. Okay, again, like we did here with our profile, I'm going to first of all mark out my contours in position. Okay, so as we know they're 5 metre intervals, we will space them out just along here. I'm going to draw a vertical line from the road and I'm going to measure those 5 metre intervals. Again, these will be ranging from 15 metres up as far as 50 metres in altitude. So depending how much of a difference there is in the metres, that will tell you how many lines of altitude that you will need to put in. So if the road itself is at an altitude of 35 metres, okay, we need to look at and see, is the rest of the ground around it, is it higher or is it lower? Okay, so this may vary in different parts. For here, I'm going to see a part C, so you're ranging between the contour of 45 and 50. Okay, so if on this place, this contour here is at a level of 45. Okay, I'm just going to start measuring out my lines and draw the level of the contours here. Just for easiness and handy's sake, I'm going to draw those lines right across so we can use them right across the drawing, depending on whether it's going to be a cutting or an embankment. Okay, so I'm just going to draw several of those in there and we can label them in relation to their heights, and this will do for the rest of our drawing. So once I have my parallel lines in here, I'm going to mark in the corresponding altitudes. We see here at this point here, if you follow the contour out, this contour line is at an altitude of 45 metres. Okay, we know the road itself is at an altitude of 35 metres, which is at this height here, this contour. So therefore this means that the land around the road between this point here over towards our left, the land itself is actually higher than the road, so we know we're going to be cutting into it in order to create the road surface. Okay, so just getting back to the labelling again, if this point here of the road is at 35 metres, I'm going to label these intervals in which I've marked out at, as we know the land is raising, so I'm going to go 5 metre intervals. So this first one is going to be 40, 45 metres, and 50 metres is the highest one. Now I know I have a few extra lines going here, but that is not necessary. Okay, so it doesn't really matter as long as I have the ones that I require for the different heights. Okay, so it's back to plotting the points again. I'm going to plot here starting at this side, excuse me. So the contour line of 45, I'm going to bring that to the corresponding point on the lines which I drew parallel to the road. So this one is here is 45. Okay, the next contour is 50, so I'm going to bring that up to the altitude of 50 meters. Again, the next contour line is 50. We're going down again to 45, again across to 40, and this last one here is 35, which is actually the level of the road. Okay, so basically you carry on through those points and draw in your curve as you see here. Okay, so where I come back to meet the level of the road is at 35 meters of an altitude. Okay, one thing as we know we need to do with this, we draw in as we use our little tadpoles just to determine on what way the cut or the embankment is rising. So generally the tadpoles do, as we say, swim uphill, so just put them in just to give you a bit of direction on which way the hill is going, so we know by looking at them whether it's going uphill or downhill as it goes away from the road. So in this case it's going uphill because we cut into the land. Okay, from the other side here we see we have our contour line here of 35 meters. So we know the altitude of the road as given in the question is also 35 meters. So we look at our other contour lines and we can see that all of those are below 35 meters. So this tells me specifically that the land around the actual road here is at a lower altitude than the road itself. So we know now we're going to be working on an embankment. Okay, so sorry, just going back there as given in the question. Okay, we were given here the side slopes of 1:1 ratio for both embankments and the cutting. Alright, so it's a 1:1 ratio. So we're going to go for every 5 meters away from the road you go, you either rise 5 meters for your cuttings or you go down 5 meters for your embankments. Okay, so just getting back to the question, again I'm going to need to plot these points. So I'm just going to draw another line here just from this point on in order to put in our measurements of the contours from here over. Okay, so because we know this is the point 35 on the road where this cut meets the road, we know from here on in it's going to be an embankment. Alright, so we know the land around the road is actually going down at a lower altitude. So if we're coming out in 5 meter intervals, remember we're going down 5 meters lower each time. Okay, so this particular one here is 35 meters. So now as I step out 5 meters, I'm coming down to an altitude of 30 meters. And again, as we step out 5, we go down to 25 meters altitude, and so on. And again, we go all the way down as far as the contour height of 10 meters, as you see over here to the left hand side. Okay, so once we have this determined and the altitude is determined on that, we basically again follow our contours and we see exactly where they are intersecting with the corresponding heights as I've drawn in here. So I'm going to start off here. We know this one is at 35 meters. Moving on to the next contour line of 30 meters, we'll follow that in until it hits the corresponding height here that run parallel to the road, and so on. We move on to the next one, which is 25, 20, 15, and we carry on right through until we plot all of those points. Okay, so now I have all those points plotted. I'm going to draw this in, and because our cutting and our embankments are going in different directions, if you like, I'm just going to draw them in different colors as well, just to make them a bit more easier identified. So when you're looking at the drawing as they get more complicated, much easier just to identify straight away whether it's a cutting or an embankment that you're working on. Okay, so one last thing to do with that drawing, we need to just show which way the tadpoles would be climbing, which is a way of identifying which way the slope is going in relation to the road. So if the tadpoles are facing towards the road, it shows us that they are swimming uphill, so we know the hill is coming from this point out, is coming up towards the road.